Hello everyone, and welcome back to part 2 of my making drawings video. We're back to our solid model on this piece. In case you missed part 1, I just showed how to do the most basic drawing, placing views on the sheet and adding dimensions. In this one I really want to focus on what's called the sheet format. So I'm going to come up here to my new icon. I'm going to click make drawing from part or assembly. It's giving me this because I've already made a drawing and it's asking if I want to open that file. I'm just going to say no so that I make a new drawing. Alright, now this is our text box that we get pulled up, and like I said, there are lots of orientations and sizes of sheet that you can do. And then there's this box. This is the one that we're worried about today. We want that checked because it's going to add the border to our drawing. So let me go ahead and do that. So far this is still looking pretty familiar. We have our sheet view, we have all of our views of our part that we could add to the sheet, but now we have this border that has the grid lines as well as the text box down here that you can you're going to be able to modify any of this, and that's going to be the main focus of this particular video. But let's go ahead and put the exact same views that we had on our last drawing onto this. You'll notice that we really don't have a lot of real estate on this at all. So I'm going to leave off the isometric view that I had on the last video, which is this fella. I just don't have space for it, and it's not necessary. So I'm just going to click the green check mark, and once again it saved everything to look like the solid model. So I'm going to click on the main view, the parent view, and I'm going to change that to the wireframe with hidden lines visible. That will add the hidden lines to the other views that I don't necessarily need. So I'm going to click on those individually, and I'm going to just change them to hidden lines removed, just like that. And like I said, you can drag up and down with the parent view. You can move it side to side. The right and left views you can only move side to side. You cannot move those up and down, but you can use those to position them on the sheet. I am not going to get into all the dimensions because we did that last time. What I really want to focus is on this. So you can still zoom in and out with your scroll wheel. If you click your scroll wheel, you can drag this around. Let me center that up, and like close that. All right. We have a whole bunch of information down here. Not much of it is filled in at the moment. This comes in pretty standard, so you can insert company name here. We have our tolerance box right here. It says unless otherwise specified. You have things that you would normally see on a print, such as the person who drew it, who checked it, engineer approved, manufacturer approved, quality assurance, a spot for notes there. Maybe you would want to type in what type of tooling you use to make that particular part or feature on that part. You have the material, the surface finish. I think these would be used if you were going to be putting this into an assembly, that you would parts that were related to it or where it was used. Over here we have a bunch of stuff that's running together, and I'm going to use that to show how to edit things, because right now everything's on top of itself and you have a few different options here. Right now I'm in the standard format, which is different from what was in the last video. If you want to go back to your simplified format, you go next to the Solidworks icon, you choose View, Workspace, and click Simplified Interface. And that will bring this up. And I want to show a couple of things here because this is all running together. You have the size of the print, you have the drawing number. Right now there's nothing in revision, but that would also be covered up by our drawing number. And we can go ahead and edit this either up here on the Edit Sheet Format button, or we can come over to the tree, we can right click, and we can edit sheet format. In the standard view, I'm going to go back to that, turn off simplified interface. In the standard view, you can still right click here for edit sheet format, or there's all these tabs down at the bottom, and I can click sheet format there and edit sheet format. What that does is turn all of the stuff blue. So you can come into any of these fields and you can start editing just by double clicking on that particular part. So this was a double left click. In the case of this troublesome drawing number, I can decrease the font size. Maybe let's go down to 16. That fits perfectly. If I wanted to actually give it a drawing number, I could go ahead and just type this in. There we go. Now we have a nice drawing number. And if I wanted to then say what the part was, let's call this stub shaft, because that's kind of what it looks like. That gives you a description of what the thing is for, and then your drawing number would be related to any future assemblies that you do. The size here is the size of the paper. Let's say that we have taken this drawing number 8675309, and this has had several revisions through the years. Your revision number would be right in here. It's actually usually a letter, so let's just say that that is revision number C. You can edit any of these fields exactly the same way. So for our proprietary and confidential information, if you wanted to actually insert a company name there and right there, you can just double click that and edit the text. Let's go ahead and put that in here. I'm going to hit caps lock so it all blends in. There we go, and it's down here as well, so let's put it right there. There we go. All right, so that's all fantastic. The tolerances, I want to point this out. My part was originally drawn in metric. If I come down here to the bottom right corner where it says inches, pounds, seconds, IPS, if I change it to millimeters, grams, second, it kicks me out of everything. Actually, I'm still in edit sheet format, but it does not change the text on the tolerances. It still says dimensions are in inches. So if you want to change that, come over here, double click like normal, and we will change that to millimeters. I don't think I have enough space to actually write out millimeters. And then you can change any of this stuff to anything you want. I don't really see fractional millimeters all that often on a print, so I'm just going to delete that. If you don't need the angular tolerances or bend tolerances, then I'm going to delete that. We can change the size of that. What I usually do see is 1 decimal place or no decimal place. So I'm just going to copy that and do a little editing. There we are. And let me copy my plus or minus. And now you've got a tolerance chart that's actually usable for this particular print. Honestly, I don't think we're going to have anything down to microns in this, but if you were going to, you could have it here. Some of you may be wondering why the heck I just changed all that and what this even means. And if you're not coming from this from a machining or manufacturing standpoint, you may not realize that the way the dimensions are actually given on the print determines which tolerance we're going to use. So for instance, if a dimension just said 6 millimeters with no decimal places, we would use a tolerance that was listed right here. Let's say plus or minus 0.5 millimeters. Let me turn off caps locks. There we go. If it had 6.0, maybe we're doing 0.2 millimeters. Let's say that. 2 decimal places, 0.1. Forgot to put millimeters there. And I'm going to change that format so it actually fits. And then 3 decimal places, maybe we would put 0.02, something like that, mm. I'm going to decrease the font size on that just a little bit. Maybe I'll make that a 5. I don't have the option. There we go. All right, still readable. Like I said, depending on how the part is drawn, we will use different tolerances. Later on in the video, I'll go ahead and add a few dimensions to the part, even though I just said a little bit ago that I wouldn't, because I want to show you how to change the number of significant digits, and I'll tell you how that relates to our tolerance chart. In the meantime, let's come down here. We'll double click material, and let's say that this is going to be 304 stainless. There we go. That would be a fun thing to make this out of. Finish would be, it could be anyway, surface finish. So if you had a certain call out for an RA rating, or it could also be something later on, if it's going to be anodized or plated or painted, you could put a note down in there. Like I said, any of this, you can double click on any of these spots. I'm going to go ahead and put my initials right there. I'm going to put a date. I'm going to put in August of 2025. There we go. There are other things down here that you can modify. Obviously the scale, I believe that changes automatically if you were to change this scale down here. Let's say we went to 1 to 2. Yep, that changes automatically. I'm going to go back to 1 to 1 though. And then if you wanted to add the weight of the part, obviously sheet 1 of 1, this would be really handy when you're doing prints for assemblies, because some of those you might have multiple views on multiple sheets, so that just helps you keep track of things. I believe you have to manually change that to 2 of 3 or 7 of 9, something like that. I think at this point I'm going to be done with editing the sheet format, and I'm going to go back to my views up here. Now let's add some quick dimensions. I'll show you how to change the significant digits and how they apply to our tolerance chart. So we're going to come over here up at the top. Again, this is the standard interface. I'm going to click the annotation tab. That's where you will find your smart dimension, and I've got that applied right now. I'm going to show the length of this hole and maybe the length of this hole, full diameter length I should say. You can see that they will snap to each other, and that helps keep things nice and clean looking. Ignore the purple box, that'll disappear, and obviously that is what you would see. I'm going to add maybe the diameter of that hole, and how's about just, I did ordinate dimensions before, so let me do that real fast. Clicking my points, drag it up there, and then I can just click all the points in between. There we go. That should be plenty of dimensions to show what I need to show you now, which is how to change the number of significant digits. So you've got a couple of options. If you want to change every single dimension globally across the entire file, you can come up here to this gear icon, which is your options tab. If I click that, it brings up this text box that has just an absolute ton of stuff that we don't have time to get into right now. But we can go to this, which says document properties right up here. I'm going to click that, and then I can click dimensions. You can see all sorts of other things that would relate to this document. But dimensions is what I want. It brings up this box that has everything to do with how dimensions are displayed. And if you wanted to change it globally across the whole thing, you can use this drop-down box and choose your primary precision. So if you really wanted it to go out to microns, you could. And now every single dimension on the page besides 0 is showing down to microns, down to thousandths of a millimeter. I don't want to do that, so I'm going to come back in here, again, go to document properties, dimensions. I'm going to leave it at 2 significant digits. Everything's back to the way I had it. Now let's say that we wanted to change individual dimensions. All you have to do is click that dimension. It will open a text box over on the side, and you can see a tolerance and precision for over here. So let's say that 40 millimeter depth is not important at all. I could say none. So now if I come down to my tolerance chart, I can see that anything with no decimal places has a tolerance of plus or minus half a millimeter, which is a pretty decent size. Well, let's say that our 15 millimeter depth is maybe a little bit more important, but still relatively loose. I could change that to 1 decimal place, and now that depth has a tolerance of plus or minus 0.2 millimeters. For the depth of a hole, especially a drilled hole, that's probably pretty unrealistic, so tell you what, we're gonna make that none as well. Don't know why you're moving. Maybe let's come up to the diameter of this 40 millimeter deep hole, this 20 millimeters. Let's click that, and this would be a pretty good one to put a 1 significant digit tolerance on. Because you could conceivably come in with a 20 millimeter drill it to roughly 40 millimeters deep, pardon me, and you could definitely hit the diameter of that to within 0.2 millimeters with a drill. It's not going to go that oversized. Maybe the overall length of 87 millimeters is not that important. Maybe we could say that that is no decimals. Let's take a look at this 37 millimeter tolerance. Maybe you want to build in a little bit of play into this feature. And so this is showing the length from the end to that shoulder. And let's say that whatever was going to be fitting onto this piece right here and retained by the retaining ring in that groove, you want to make sure that it's going to fit. So you can click on that dimension, and over here above where you would change the significant digits is this tolerance drop down. You have a lot of options here: basic, bilateral, limit, symmetric, min and max, and fit. The one we want is bilateral. So that's going to open some additional bits here. You can see that it added some numbers over by our dimension. And let's say that we wanted to make sure that it was absolutely no shorter than 37 millimeters. We would have a minus nothing. But let's say we wanted to make sure that whatever fit in there fit great. And we'll say that it's plus or minus 0.2 millimeters. So right there, it gives us a plus 0.2 millimeters minus nothing. And that means that our tolerance for that would be at the lowest limit 37 millimeters or 37.2 at the highest. You could easily change that to a limit tolerance, which will give you both numbers right there. And if you wanted to change it, you could just change the text here. So anytime you see a tolerance that looks like that, 37 is the minimum and 37.2 is the upper limit. I should say lower limit, upper limit. Real quick, I'm going to come in and I'm going to add this 25 millimeter diameter. That would be the diameter of this shaft right here. And that seems like the kind of thing where you would want a tighter fit if something was going to slide onto that. So I'm going to make that to 3 decimal places. And if we look down here at our tolerance chart, that would give that one a tolerance of plus or minus 0.02 millimeters, which is pretty tight. And of course, if this was something that you needed a mating fit on, something was going to slide over that, realistically you would have a plus nothing tolerance minus something tolerance here. So it might be an instance where you would want to do a bilateral and maybe something like that. By the way, you can also change the precision of the tolerance right here. You can see the dimension is given to 3 decimal places. The precision of the tolerance can be changed either individually or if it's shown as same as nominal, it will just convert to whatever the dimension is given. So if I change that to none, well, that doesn't work. If I changed it to 2, then you would still see your tolerance, but it would be in the same number of digits as that. There would really be no particular reason to have that out to 3 digits if you're going to throw a tolerance on there that supersedes what's in the chart. Anyway, I'm just winging it here, so don't judge me too hard on this. That should do it for this particular video. Let me know if you've got any questions about this or any other SolidWorks or machining topic. I'll try to cover it in a future video. Thanks for watching. Have a good one.